All right, so these next two problems have to do with inelastic and elastic collisions. The first problem has to do with an inelastic collision. All right, Carly, can you remind me what happens in an inelastic collision? What's that? Yeah, so two objects hit, right? They collide and they stick together. Good. So in an inelastic collision, two objects hit and they stick together. Awesome. All right, so we've got a problem here that says a railroad car of 2,000 kilograms coasting at 3 meters per second overtakes and locks together with an identical car coasting on the same track in the same direction at 2 meters per second. What is the speed of the cars as they lock together? There you go. So with these problems, the first thing you want to do, because they're not always going to tell you directly, hey, this is an inelastic or this is an elastic collision, you need to identify which one is which. Excuse me, right? So if it says something about them locking together, sticking, not breaking apart, then it's an inelastic collision. All right, so first thing we should do, we've got two railroad cars. We have railroad car 1 with a mass of 2,000 kilograms. And we have railroad car 2 that also has a mass of 1,000 kilograms. Okay, so we write the two of those down. Now, railroad car 1 has an initial speed of 3 meters per second. And railroad car 2 has an initial speed of 2 meters per second. So you can see where it becomes important that you put in your subscripts properly. Initials and finals, 1s and 2s and all that. And they hit and they stick together, and we would like to know what is the final speed of the two of them together. So here's the way I think about it. There are specific equations for inelastic and elastic collisions, but I don't think about those equations. I think more about the momentum of each individual object. Okay. So before they hit, how many objects do we have? Right, we've got two objects. So before the collision, we've got two objects. Is object 1 moving? Right, so object 1 has momentum. Is object 2 moving? So object 2 has momentum. So that means I need two momentum terms. One for object 1, one for object 2. And so I have m1 v1i for object 1. Here's the momentum for the first car. And then m2 v2i, which is the momentum of the second car. Okay, and this is again before they collide, before they hit. So they come in, and they're actually traveling in the same direction. And then they smash into each other, okay? And they lock together. How many objects do we have after they collide? 1. All right, we've got one object now. All right, it's two objects, but they collide and they stick together, so they act like one. Okay? Are they moving? Most likely, right? We don't really know, but most likely. Okay? How many? So we got one. So how many momentums do we have? We've got one momentum, right? Now, it's mv, but what is the m for this one object now? Chris? Yes, the sum of the two things together. And then we have our final speed. Okay?
Total dash on the first v. Like, see, there's m1, v1, and what's up there?
I. Okay. So now we just go and we'll plug in. We've got 2,000 times 3 plus 2,000 times 2 equals 2,000 plus 2,000 times v sub f. Excuse me. And so we've got 6,000 plus 4,000 equals 4,000 v sub f. 10,000 equals 4,000 v sub f. Or if we divide 10,000 by 4,000, we get that v sub f is equal to 2.5 meters per second. Does that work out? Yeah, 2.5. Good? Do we have any questions? No? Okay, so once you determine what type of collision it is, right, everything tends to fall into place. Right?